All right. Hello, everybody. I'm a bit late because I had to eat some breakfast. It's the developer guy. Yeah, it's me. It's me in the flesh. Or are you talking about Gandalf? Now I don't know. So let me quickly show you what I've done yesterday after the live stream, which is not much. What is Rust and Bevy game development? Game development in Rust using Bevy. I don't know. What answer do you expect? Let me actually open some of my apps. Straight from watching the Jet Lag season finale. Is that how you say that word? To hear, my night is all set. I'm happy to hear that. So if you don't remember, or if you weren't there yesterday, we are working on gameplay mechanics for my puzzle platformer game Astortion, I guess. Here's a list of things that we need to do. We currently implemented anchors. Yesterday we started implementing hooks, and they mostly work. And then after the live stream, I implemented walkable walls, and also did some cleanup when it comes to how we handle them, because that's something we also implemented parts of it on the live stream. So let me just quickly launch the game. Finale, yeah, okay. Okay, so here's the game, and now we can actually, approach this walkable wall, which is here. It's a bit difficult to see because they are drawn on top of each other, right? The orange line and the white line, but the section of this wall from here to here should be walkable, and it actually is. Right, I can now sort of, move on it as if the direction of the gravity was always facing towards the wall. And a few changes that I made since the last time. Now in Blender, when we have our ground, the walkable section is actually a nested object inside of it. And on this object, hold on, because chat is a bit obscuring the view a bit. I'm gonna try to. I need to set up like a separate scene for Blender, I think, so that you can see better. Excuse me. Okay, and this walkable object now has the walkable property, right? So it defines from where to where the walkable section is. And I have an idea for improving it so that I don't need to guess this parameter, because this parameter is basically, the time along this curve from 0 to 1, where like 0 is here, the beginning of the line, and then it goes all the way around. So it's a bit difficult to estimate where it's gonna start. You just need to randomly guess numbers. And my idea is to specify it, instead of using numbers, specify it using points. And then in Bevy, when we parse this file, we're just gonna find, okay, what is the closest point on this curve, and just use that, right? So this way we would just set it up visually in Blender, and it should be much nicer. When it comes to actually changing the gravity, I did some refactoring of the code that we wrote previously. So the main thing we did, which maybe at first glance wasn't that important, but we made this system for drawing our walkable section, right? And you can see that it's changed a bit. A quick question: does the shift to Rust and Bevy mean you lose all the nice tools you made for Unity dev, or have you adapted them? I'm trying to avoid making tools, but yeah, I lost them. I mean, it depends what you mean by that. I have a video where I sort of go through something like Reanimator and how I used to implement it in Unity versus how I implemented it now in Bevy. And from my perspective, it's much simpler and doesn't require that much work. And I will make another video like that about typewriter, because like the basic idea and the way it works is sort of transferable between game engines. Because I can actually show you this quick little tangent. If I go to the typewriter website, you can see that there's runtime API and there's editor API. And in reality, runtime API is what actually handles all of the dialogue and so on. And creating it was really straightforward. This is like, you know, few days of work to make it happen, because it's a really simple idea, right? Fundamentally. And then the editor was like 3 months to make, right? Just for the sake of having a visual editor. So in my current approach is just to avoid making visual editors altogether and just focus on this, you know, the thing that actually does things in the video game. And when it comes to Bevy, translating typewriter into Bevy is going to be really simple, because typewriter sort of is an ECS system in and out of itself. So having an actual robust ECS system to implement it is going to be fun. But I'm going to have a video about that as well. Yeah, so we were drawing the sections of the walls that were walkable. And now, instead of having this whole, you know, for loop in here that figured out which paths of the Bezier curve were, you know, inside of that section, which we were, you know, figuring out during last live stream, is like, oh, if we want this section, what portion of this segment of our spline is actually within this range, right? Instead, I made a little iterator, my first ever Rust iterator, segments in range. It takes the path and it takes the walkable range, and it returns an iterator over only the segments that are within this range, right? And like the implementation is basically what we wrote last time. First of all, we have the state, which only stores the range and the original iterator over segments, and also the aggregated length. And then we have the exact same for loop in the next function, right? So just like before, we have our early out with accumulating the length, which was the error. Not having this was the error during last stream. Yeah, and then just, you know, making a subsegment and returning it. This is a really cool setup, by the way, because I stole it, right? By the way, it's important to note, I guess. I stole it from the segments implementation from Velo. And I don't know how exactly it works. I mean, I guess that the segments iterator that we store, it sort of remembers the current index, right? So each time next is called, we sort of resume this for loop, and we can like continue and break and so on, and then we just return the next value. And then when next is called another time, it comes back to this loop, and it works nicely. And it's really nice to have this logic separated, because now right here we have a new system parameter which is designed for like finding the closest point at a walkable surface, right? So it queries for our walkables and for the curves. And now it's a bit different because, you know, curve points are no longer on the walkable, because walkable is now a child of a curve. And then I just have a simple closest function implemented for this system param. right? So I can just ask it, what is the closest point at some walkable, whatever walkable this may be, at this position, and this is the maximum distance. So if we are further than that or farther, it's not going to return anything, right? And it returns an option. And here you can see that I'm making use once again of the same iterator. This is basically, you know, the typical like, oh, are we closer than the closest distance? And if so, we sort of calculate the new value. It's like a really simple search. It should probably be optimized a bit more with like some AABB, you know, cross testing or whatever you call that, intersection testing. But that's something we can do later. And then with all of this, you know, setup, if we go to our player controller, right, the free run state where we sort of go wherever we want, you know, it's pretty simple to handle because we test like, oh, are we within the distance of some walkable, right? Using this is the player position, and then 20 should be probably a constant, but it's the player radius is 12, so this is like 12 plus 8, you know, some error margin. And if we are close to something, we just change the physics. Yeah, and this is pretty much you know, all there is to walking on the wall, making it work as expected. When it comes to other gameplay elements, there are certain things that also change gravity, right? So for example, the extraction tunnel is going to change gravity and fields are going to change gravity. And the way I think the best way to make it work, I think, is just have a hierarchy of have a certain priority assigned to everything, right? So if there is an extraction tunnel that goes through a field, then a field should take precedence, right? A field should be like, oh, I'm gonna modify the direction. We could do other things like, you know, adding them together, but I don't think it's gonna be necessary. I feel like just having them override one another, with field being the most important one, extraction tunnel being the second important one, and the wall walking being the least important one. Right, so then this should be really easy to handle here. It's just gonna be a few if statements. And this is the plan for today, to sort of handle this, see if the hook is working nicely together with the wall, figure out how to properly do launching, and then maybe we're gonna have some time to implement picking up objects, because that would be cool. It's the plan for today's stream. You read the Rust book? I read the Rust book a few years ago, and I only read like half of it, so I need to go back to that. That is, yeah, another disclaimer for new people here. I don't know how to code in Rust. I've been doing it for like a month, I guess. I like how smooth the rotation is when you're walking on the walls. Yeah, that's also something that I added. First of all, thank you. But yeah, now in the update animator, we are also changing the rotation to face the gravity direction, right? I don't know if there's an easier way to do that, to create a quaternion from the up direction, especially in 2D. So what I'm doing is I'm just taking the angle of a perpendicular vector, of negative perpendicular vector. So it's gonna be, you know, if this is up, this is up, this is perpendicular, and negative perpendicular is gonna be here. and I'm just passing this to from axis angle to rotate around the Z axis, which is, you know, the one facing the camera, or maybe facing away, I never know. But as a result of that, if I quickly launch the game again, but this is of course something that we're gonna have to work with too. If I use an anchor, I'm also now rotated towards it, which I think is a bit nicer, shows what's happening here. But again, you know, visuals, who cares? Visuals will come later. Okay, so still haven't changed the name of the app though. I don't even know how to do that. I guess we can do it just for you. Let me quickly Google this. In the window plugin. Okay. Here we go. Is game dev in Rust normal? Pretty much no. I don't know what you mean by normal though. Here we go, Astortion with the default Windows application icon. I don't have an icon. I mean, I have it somewhere, but I don't want to look for it. I guess I'm gonna set it up after the stream. Okay. So now I guess having all of this I just realized something. We're also gonna need to find the closest point on the extraction tunnel. Oh man. But this function is really specific to walkables. So ideally we would find a way to like reuse this logic, because I don't want to copy paste it. If we could only get this loop to work, right? I wonder like what are the requirements? What does it need? It needs a lot. So yeah, we definitely need the entire transform. And what is this transform of? This is the transform for the curve itself. Also, I just realized I shouldn't be using this transform because it's a child of the curve. So it probably should be the transform from the curve. Doesn't matter right now, but we should definitely fix that. Okay, if I were to take the transform, right, or like even a reference to the transform, then we have the position, which is the position that we want to query, and probably distance is also somewhere here. What else? Oh, I mean path, that's for sure. Okay, and this is actually a global transform. Oh. Hold on, I think code is sort of messing the highlighting. Oh yeah, that's better. And then we probably want to return closest, whatever that is. It's not declared anywhere here. Okay, and now the question is, oh, okay, we use path for control box as well. I guess that would have to happen outside. Well, that's a bummer, because ideally we would pass the iterator here, right? So that we can either get something in the range or get something not in the range. Or we could just pass the range from 0 to 1 and just not care about that. I feel like that would be the easiest solution. Not the optimal solution, but yeah, I guess for now we can just do that. Find a way to reuse it while always using segments in range. Easy solution would be screw it and copy paste. Yeah, that's true. That is true. But I so desperately don't want to do that. Hey, first of all, let me just quickly fix the... let's try to break it first. Knowing that it doesn't take into consideration... Oh no, but it's gonna take it. Or is it not? If I were to move this walkable somewhere, right, this should break it because we're using the wrong transformation. The position of this walkable should not matter. So I'm just gonna quickly save it and see. I know I like doing it this way, you know, seeing a bug and then trying to use it to break the game. Yeah, so now it doesn't work because it doesn't consider us to be close to the walkable. We just cannot use it. And the solution would be to actually take the global transform from the curve and not from the walkable. So just paste it in here. And now, what do we have here? Yeah, this transform is no longer gonna be here. And this is gonna be points and transform. Should be pretty straightforward. Oop, maybe not. Something, okay. I'm missing tuple. Yeah, now it's compiling. And now it should work. Okay, never mind then. This is kind of weird. Yeah, because this is the correct transform. Okay, so let's try moving it back just to see if that fixes it. Hey, what are you doing currently? We're implementing gameplay elements. Okay, so now it works. Okay, that's silly. I don't know why it has this effect, because we're not even using the global transform from within this thing. Hold on, I'm gonna run it. I'm gonna run it without hot reload, because I didn't have hot reload watcher running in the background, so maybe it just didn't update, you know, the code. I'm pretty sure that's it. Nope, physics. Oh, physics is not working at all now. That's interesting. Okay. Yeah, all right, now it works. So that's fixed. We're implementing gameplay elements. What do you mean? That, I think it's a good explanation of what we're doing right now. Okay. I need to think about. Oh, we want. Okay. I keep on forgetting what I'm working on. Extraction tunnel. Somebody said just copy paste this. But how? Hold on. How is the extraction tunnel implemented right now? Because it's kind of important. So it's just a curve with a tunnel property. Okay. Which we set up here. Okay. All right. So that should be easy. But also, what's gonna be a bit annoying is the fact that we need to make these things not collide, right? These two system parameters, because this is gonna take curve points with global transform, and the tunnel thing will have to do the same thing. Yeah, but I'm copy pasting it, by the way. You convinced me. So this is gonna be just a tunnel query. Closest tunnel. And then implement the tunnel query to find the closest. Let's see. You know what we could try doing, I guess? I don't know how to set it up correctly. Can I just make a module called extensions? Because I keep having to like transform vector into point and so on, right? And so maybe what we could do, if we add this here, we could just implement, make a custom trait, right? And implement it instead. So, I don't know if this is idiomatic Rust, but we could just have a function here, right? That would be like 2 point, or maybe not 2 point, as point, I think is the convention, right? Orphan rules behated, yeah. Yeah, and this is gonna return point if I can find it, yeah, from Velo. Oh wait, I can't do that in a trait. Right, and then, oh, what's up? Okay. Yeah, so this is gonna be for the vector, and then this is gonna be for the point, and hopefully it's gonna be less verbose. Also, since they're probably copy, you can write it as function into underscore star self and avoid the reference. Oh, you mean, okay. I thought you meant like a different syntax or something. Is it better then when you do it this way? I don't know. It's not, it sounded like I'm disagreeing. I say like I don't know, like genuinely I don't know. If he will complain about copy pasting code, tell him please about rationalizer action on selected code. Yeah, I read your initial message about that, but it's like it's not a problem of extracting code. It's the fact that the code is written, you know, in the context of walkables. Like things here are using walkables. Walkables are being queried, and then, you know, iterators are being set up here. So I can just, you know, I'm not copy pasting it because I can use it as is. I'm copy pasting it because I'm gonna have to modify it. And I cannot think of a way of reasonably generalizing it. And it's also the second time. Everybody knows that you can only generalize after the third one. Okay, so now we should be able to just, yeah, do this a bit nicer. Okay, something is wrong. Why is extend not here? Oh, so it's the wrong vector too. What do you mean by that? That's crazy. Oh no. Oh no. Oh no. Oh, it's as vector and not to vector. Okay. Because the struct itself already has a function like that. Well, that's gonna be annoying. Okay. You know what I would like to know? What is the shortcut in Visual Studio Code to go to like the previous error or the next error? If anybody knows, I'd love to hear that. I think the convention is that as x takes self by reference, whereas into x takes self by value. Oh, so maybe we should call them into. Avoiding references is better because it avoids the referencing with optimizations. With optimizations, it probably doesn't matter, but Rust prefers it when you use its move semantics. I see. Wait, but I see you're arguing about like performance and whatever, but that will like this will like consume my value though, right? So in some cases, like here, I mean, okay, it's a bad example because I overshadow the variable. But then if I wanted to, you know, I don't know, debug tangent here, I'm not gonna be able to do that, right? Or will I? Maybe I will. That's interesting. Okay, I don't know. Because I thought it's gonna move the value out of this, out of the scope here. Okay, anyway, we have some more errors. Can I omit the referencing here? Okay. Hold on, let's try to be smart about this. Okay, will this compile? No. Yeah, because now we need to go to the tunnel and fix everything here. Segments in range, is that a public function? Yeah, okay. Oh, system parameter is not in the thing. Okay, so this is now gonna return an option with closed tunnel. And what do we need here? We still need position, still need tangent, probably all of this. So I guess there is no point in redeclaring it, right? I could probably just rename it to something like, you know, closest point. And then use it here as well. All right. It's probably, yeah, from a different file, and now we can use as vector here. Oh wait, we're missing this as well. And derivatives. And okay. So now we're not interested in walkables anymore, we're interested in the tunnel. A part of me kind of want to make this a generic type argument of the tunnel query, but no, that's gonna bite me in my tail later, so let's not do that. And then both walkable and tunnel could implement the same trait, right? That would get the range, and the tunnel would return a range from 0 to 1. And everything would be perfect. I mean, actually, oh wait, but now, never mind, because these are not two separate entities anymore. This is actually the same thing. So we don't need the whole parent thingy. We don't need curves. This should probably be called tunnels instead of walkables. And then it's tunnel, then it's points, and then it's transform. And we don't need this. Okay. Yeah, and it's not parent, it's just entity, which we are not querying for. Okay. Oh, and tunnel is only like a little tag. So we can just use with. There is no information in the tunnel as of right now. Okay. A bit too much duplicated code than I'd like, but at the same time, what's the point? So question that I'm a bit afraid of is what's gonna happen if I use that query parameter here, right? Because they use the same data, but at the same time they don't mutate anything. So I think they should be compatible, right? If they just reference things without mutating them. Okay, so extraction tunnel is gonna be is gonna have higher priority over walkable walls. We're gonna need some additional logic here because we kind of, with a wall it's really simple, right? Because a wall is just like, why is my brush so big? The gravity is just like in this direction, but with an extraction tunnel we need to keep the gravity towards tangential to the path, but at the same time we sort of need to apply some corrective force to keep the player on the curve. And it should be relatively easy because closest will give us the distance, and if we know the distance, well, no, distance is not going to be as useful, but it gives us the world space position, right? So we can see that like, oh, the player is kind of too far away from the curve, so we can apply a force to keep it back on track. That's the general idea. But for now, let's just set the physics up to be whatever the tangent is. Also, I don't think this is the tangent. Now as I think of it, hold on a second. Would it be the tangent? No, because no, it's not a tangent because I'm taking the perpendicular vector, so it's actually a normal. Man, I hate this. It has to be normal. I knew that it doesn't make sense that I use tangent as the vector for gravity, and it just worked. Oh. Okay. That's more sane naming convention. What just happened? I thought, okay. I thought I was spacing normal. Okay. Does it run, though? That's the question. Hello there. Hi, welcome to the stream. To jump to error in Visual Studio Code, press F8 or open command prompt with Ctrl-Shift-P and paste go to next error. Okay, I'm gonna try it. So here's an error, right? Oh, but it's also showing me warnings. It's showing me all the problems. Of which there are plenty. Okay, so now, what's wrong with you? Oh, let's truncate this. And now let's run. You can press Ctrl D. I don't think I can, because I set it up to duplicate the current line. Yeah, but this is probably a better way to do what I just did. Okay, so the wall should work correctly. And work correctly it does. And then the extraction tunnel. Oh. Something is happening. I feel like we probably... It's almost working. It's almost working. Kinda. Yeah, okay. I'm pretty sure we need to draw the tunnel, because without that... Without that, it's gonna be really difficult. So we are already drawing something here, right? There's like a draw walkable. Oh, and we even have like a little draw Bezier path function here. That's awesome. We'll just make this public. And we're just gonna add a new system here. For drawing the tunnels. So some gizmos, I suppose. And the tunnels. Okay, so all we want is the path. So all we really need is just reference to the curve points with the tunnel tag. Oh, and it should probably use a reference. Okay. And what's wrong with that? Oh, okay, because that's not the... Okay, wait. So it was correct. Actually, we don't need the reference here. All right. Now let's run this. And then we can take care of, applying the forces correctly. I also don't know if I want the player to control the direction or if the direction should be always the same. If the direction was always the same, that would be like a really typical Portal 2 ripoff. Okay, so a few problems. First of all, the path is closed by default. But other than that, it's visible. In Visual Studio Code, Alt-Shift, up-down, arrow key duplicates the line. Yeah, I know that there's a default shortcut for that. That's not the reason I set up my own shortcut for duplicating the line. Is not because I thought that Visual Studio Code doesn't have it. It's just that it's too embedded in my head to like get used to new shortcuts. So I'm assuming we could fix this, right? If we were to simply maybe have an argument here. See, because we're just closing the path here manually. What would happen if this wasn't there? So I suppose for the most part, we want the curves to be closed. But yeah, for something like a tunnel, we need an ability to make them open. Okay, nothing changes. And I'm afraid it's because the points that I'm exporting from Blender already sort of include the closing element, I suppose. Let me quickly check. Okay. This is Python. I know. Okay, no, so for extracting, we're just dumping the position of like handles one after the other. So like left handle, center, and then last handle. So this has to happen somewhere in the parser. Okay, I already hate this. So curve points itself it's storing just a bunch of points. Oh, okay, no, so it stores the data as is. This just sort of collects the tuples of like 2 points. Yeah, because we're storing x, and then we are pushing x with the current number as a vector. Okay. So now I'm clueless. We start with the first one, and then we iterate over not a window, but a chunk of 3. And interestingly enough, the first one here is the last from the array. Man, what was I doing when I coded this? Oh wait, no, it makes sense. Yeah, the first would be the last point, and that's probably what's making it close like that. So if we want it to remain open, I suppose. So what changed here? Oh, okay, this. If we wanted this to remain closed, what we would need to do is take the first one, oh, okay, but chunks is a method on a slice. That's a problem, because I'd like to skip the first one and then do chunks. Yeah, let's just try what's gonna happen if I do this. First, actually, wait, hold on, I lost the message. First actually takes the last point in the self points vector. But what do you mean by that? Why would it do that? You can also index the points array with 1 dot dot to skip the first array. But I'm not indexing them. Oh, okay. So anyway, I opened the game and this is how it looks like. So something is up. This is the tunnel, and here are the curve points. Yeah, so we go progressively to the left, right, like this. Yeah, it's a bit difficult to visualize what's happening here. We quickly take a look at this spline. The positions, because the positions are the same, you know, here and there. Do you want windows or chunks? Exact. I want windows. I want chunks. I mean, I have them here. Because what this function is doing, it's starting with the first point, and then it's doing cubic Bezier with the first handle, the second handle, and the end. That's how this API works. Curve 2, right? It's like the end handle of the current point, the start handle of the next point, and the position of the next point. So we don't want them to overlap. I'm just a bit confused as to which one is the first and how they are laid out in the array. Because they should be ordered like this, right? Starting with this, then this one, then this one, and then this one, and this one. So if it's open, no, never mind. I guess you could just debug it. What's the point? I like to, you know, think pointlessly about stuff. I mean, I can, okay, let's make sure I understand how they are positioned in the array. So this should be relatively straightforward, given that they have the same positions, right? It's not the walkable, it's this one. Curve points are here. So we start with this, right? Negative 2.9 and negative 2.6. So this would be negative 2.9 and negative 2.6. So we start with this handle. This makes sense. So I made it so that the closing segment is the last segment, right? Let's just make sure that that's the case. The next one is negative 3.5, negative 1.7. Yeah, negative 3.5, negative 1.7. So the next one should be negative 4.9, negative 1.7. Yeah, okay. So we start with the end of the first handle. So basically all we need to do is iterate this one time less than we have to. I don't know if it's possible to do that though. Maybe rename P1, P2, and P3 to something more clear. You mean rename an external method from a different crate? Or do you, I don't think I'm using P1, P2, P3 anywhere else. self points, iterator, take, self points, length, -1. Yeah, but then I cannot call chunks exact on an iterator because it's a slice method. I guess I could do it here, right? But I don't know what's the length of this. Oh man. Iterators. I can use take, but then I don't know how many. I would need to like manually do the calculation of the length, right? Points length -1 -1. No, I cannot do that. I would have to divide it by 3 and floor it, I guess. Or maybe I could just subtract 3, right? I guess this would work. Let me restart and see what's gonna happen. Okay, still not what we want. Okay, but this should still be last. This is correct. Let's run it normally, just to make sure that everything is correct. I think it has to be before, not after. I can't do that before, because I cannot call chunks on an iterator. Oh no, yeah, no, this is wrong. This is completely wrong. This would have to be like divided by 3 -1, right? Hear me out. What if I just use a normal loop and do this manually? Okay, here it is, I guess. I guess it works. So is integer division flooring the value by default if it's a positive number? I hope so. Okay, so now we can just add a new parameter here, I suppose. Oh, hold on. It has to be mutable, I guess. Also, I just realized how confusing this naming here is. Because it's a window. Yeah, and then... And we're golden, I think. Or maybe not. Yeah. I guess we can't really do it this way. You need to box the iterator to make it not have different types. No. I mean, I know that I can do that. I cannot do that. That's the wrong language. But I'm just gonna go for this. No, I also cannot do that. Hold on. Okay. Because an if statement also needs to have some sort of a return value. Okay. Okay, guys, hear me out. I have a plan. I have a solution. Here we go. No one needs to know. You can take a reference to a dynamic iterator, but that is also somewhat insane. Like, yeah, like this, because it's known at compilation time, right? I guess in my opinion, the body of these functions, the bodies of these functions diverge enough to justify separate functions. Okay, and this is also a chunk. Here, be my guest. My guest. Is that how you say that? Yeah. Into closed path, into open path. Everybody's happy now. We can go back to whatever we were doing. I think it would have been fine just calling path, close path conditionally instead. But no. What do you mean? Were you not there when I struggled? We do a different thing here. The open path needs to skip the last chunk of the array. Like, that's the problem. Like, yeah, we could have an if statement here. That's not a problem. Oh my god, guys, this works. This also works. Okay. Okay, we fixed the drawing function, but the function that finds the closest path. See, oh my god, this is perfect actually. Because we duplicated the function here, all I need to do is just change this. And not worry about the fact that like the function for walkable curves is using a different thing. If you didn't know what just happened, the force was applied on this path, but it was also applied in this direction. I don't know if it was visible, but I could feel it. Yeah, and now it doesn't try to grab us in the opposite direction. Although it is a bit difficult to verify. Okay, so now let's actually switch to hot reloading, because we're gonna work on this. We're gonna work on the forces, and I feel like it's not gonna be something that I get right first time around. As if anything I did today worked for the first time. This is why code repetition is good. Yeah, I mean, like why I'd say early abstraction would be bad if we were to do it immediately. Okay, so first we need the vector from our player to the closest position. And let's truncate this. Now we're gonna need to get the horizontal component of the current velocity, because that's what we want to modify. So it's gonna be physics velocity, and then we need to take the dot product with the vector. And now we can subtract that from the velocity. So we should be left only with the component that's perpendicular to or parallel to the tangent of the curve. And then we need to adjust the y velocity, the x velocity, to make sure that it stays on the curve. Right, so what I'm trying to do is I'm trying to split velocity into two components, the one that goes alongside the curve and the one that's perpendicular to it. And we basically want to get rid of it and add a component that will, drag it back towards the center. Let's see what's gonna happen with this alone. Okay. Not necessarily correct behavior. Oh, I'm silly. And we want to multiply this. I was subtracting a float, which weirdly enough, there is an operator for that, for subtracting a float from a vector in Bevy. Okay, interesting. I'm not normalizing it, am I? See, we could technically normalize it, but I feel like we don't need to calculate all of this, because the closest normal will already be exactly what we need. Maybe truncate this. Okay, so now we don't get overshot because of it. And the velocity is only going alongside the curve. But we're still gonna wanna call it normal. Actually, we're still gonna wanna calculate the distance. And actually, maybe we just need the length, right? If we know the length and we have the velocity, I think we could make it into a spring, right? So physics.velocity, we would simply add the, oh, so this should be normal. We could add the normal. Well, we actually don't want the length. We want the dot product with the normal as well. So this is gonna give us a number. This is gonna be either positive or negative depending on which side of the curve we are. And then technically we should just be able to like do this. And maybe it would even work. Let's see. Yeah, okay, so it slowly snaps us to the center. But it's really stiff. We basically kind of like hit the wall. So what we can do is something that I'm already doing with the movement. So I'm just gonna steal it, I guess. Man, all of these commented out portions. Yeah, we're doing a little damping here. So yeah, let's copy this. Let's copy this and use it here. And let's make x mutable. So current velocity. Oh no, it's control velocity, yeah. Okay, so what we do is we calculate, and we need to come up with some damping, right? We calculate the normal velocity that we want, right? And by normal, I mean the velocity that's normal to this curve, right? Or perpendicular to the movement direction. And then, oh wait, hold on, this should be here. And then we calculate the difference between the velocity that we want to have and the velocity that we have. And we adjust the current velocity that we have by this difference multiplied by time, multiplied by some damping factor, and add it back. We subtract this from velocity and then we add it back. And so it should give us this nice smoothing kind of feeling. And I used 8 for this, which I guess is too big. Maybe let's go for 2. This is the same damping used when we are in the air. Okay. So now, yeah, the damping is maybe a bit too slow. Maybe let's try 8. Oh no, I closed the game. out of a habit. Let's trigger a reload quickly. Okay, so we probably also want to increase this thing, right? Maybe let's see what's gonna happen if we just use speed here. And then, you know, make some huge value here. So the damping is gonna be basically non-existent. No, that's way too big. Speed is huge, right? Yeah, it's like 240. Let's try something smaller, like 4. Wait, I don't think I can just increase the damping like that. Now as I think of it. Let's just add the difference here as is without any modifications. Oh, it's not the operator. Okay, so now this nicely keeps us nicely on the path. Now let's go to the damping. Maybe something like 8. Okay, so it's still not good enough. Like, it's nice and smooth, but it's too smooth. I'm thinking on how to solve this. Oh, also we still have air control while we are in the tunnel. I don't know if we want that. Because then we could like escape from the tunnel, maybe. Yeah, I'm gonna think about this because I don't feel like thinking about this on the stream. Because I need to sort of focus and think about, you know, how to implement that. I think the idea of like being able to, you know, escape the tunnel is kind of cool. Maybe instead of trying to use physics, right, we could technically just log the velocity completely. Right, so this could be like x plus y, and then y would be, you know, the same but perpendicular. So this is the y component. And actually, we don't even have to care about the y component just yet. Because the y would just be normal times speed, maybe. Oh, okay. That's bad. Let's unfreeze the physics here. first and foremost. And let's use like control velocity here, just so that like it's just exactly the velocity that we want to have and nothing else. It really doesn't want me to go there. Oh wait, because, okay, it should be perpendicular. Okay, and probably negative, just because of the direction of this tunnel. But yeah, the direction of the tunnel is another thing that we're gonna have to figure out. Ooh, or maybe not. That's weird. It is pushing me to the center, but nothing else. Yeah, it just changes slightly. I'm looking if maybe some of the dashing here is interfering. So let's just get rid of it. Oh, too many changes. No, so what's happening? Just ignore control velocity altogether and just use, you know, the perpendicular value. Okay, and a negative perpendicular value. So it's like pushing me from the right to the left. Interestingly enough. Can I maybe get there? No, it's too far away. Sadly. And just normal would be what? Okay, this is crazy. Let's not modify the velocity as well, but it doesn't matter because all we really do is just set the velocity to a constant value. No, the normal is the normal vector. I fixed that. You know what? You know what would be a smart thing to do, actually? What color could that be? Oh, something's wrong. Expected vector 2. Oh, that's interesting. And let's also make it bigger. Okay, it did not like that. Crimson, obviously. I want to try cyan though. Yeah, so that's the normal. And I'd say that's normal, right? But then when we do perpendicular... Oh, you know what could be the problem? Yeah, so that's perpendicular. And then that would be a negative perpendicular, right? Yeah, so I have no clue. Oh. I know what's happening. Ground snapping is trying to keep us on the ground. Now if I set the up vector to perpendicular and set this to a negative perpendicular, it should realize like, oh, this is now the ceiling, so we shouldn't try to snap to it. Yeah, okay. Okay, so that's pretty nice. I would say so myself. Now we can go back to this. And we could add X to that. Okay. That's much better. And now maybe we can also add some of that for the Y. The control velocity for Y would be this. And we want to get the difference. And here we probably want even more snapping. And then we just do that. But interestingly, now it also overshots the thing a bit. So maybe this is not that great of an idea. Maybe we could just, for now, set Y to this and then worry about the dumping. Oh, but now it happens all the time. Okay. So what changed exactly? Oh, is it because I'm modifying? Because I'm actually modifying the velocity? No, but I was doing it. Hold on. What was I doing before? I set the up vector. And then I added damping like this. Okay, let's go back to that. Yeah, and this is kind of nice. I guess it's because it's a spring, right? So because it's a spring, which means that the velocity is sort of based on how far away we are from the curve. When we sort of move the player in this direction, you know, the spring tries to push it back, but it doesn't really, it's not strong enough to do it. And that's why we sort of not really hit the tunnel directly, but instead we're always sort of on the right side a bit. You can see that the center from the vector is being drawn. It's always on the right. Yeah, but that's just math. I'm gonna have to figure this out eventually. For now, I think it's okay to be this way. So yeah, we have the extraction tunnel that only works in one direction for now. And you also cannot escape it, which I think is good. But we'll see. No, I actually don't think it's good. I think it would be much more fun if you could try to leave it like in the middle. Anyway, it's been 2 hours. So I'm gonna look at the chat, see if you're saying anything interesting. I don't think he reads chat. Yeah, I'm trying to, you know, come back to chat every now and then and not read it constantly because I would not be able to focus on anything. Can she accelerate the player in normal instead of setting the velocity? No, because I want it to be a constant speed thing. I don't want them to constantly like accelerate. I could, and this is what I initially did. But it's the player will just like continuously sort of speed up until the drag, you know, slows you down until you hit like the top speed. But I don't want you to hit the top speed because, you know, the top speed is something that happens when you fall down, right? It's like at some point as you fall down, you're gonna hit like the maximum velocity. And I don't want the extraction tunnel to be that fast. I want it to be slower, mainly because I want the player to be able to like leave it in the middle of going through it. Because I feel like if the tunnel were to just like take you from place A to place B, it would be boring because there's not much you can do. It's just like at this point this could just be a, you know, a teleport or something. But when you have this added option of like, oh, I can, you know, leave in the middle and try to land on something below it or whatever, I think it's more fun. And Portal 2 did it. And everybody knows that, you know, it's the greatest game of all time. So they never made any mistake in their design decision. cap the speed in the tunnel. That's what I'm doing. I'm by setting a constant velocity, I'm capping the speed, right? I could make it accelerate slowly to that speed, and that's probably something that I'm gonna do. But it doesn't necessarily have to be physics based, right? It can just be damping. Valve did one thing wrong with Portal 2, not making a sequel. Yeah, that is true. Thank you for Motion Canvas, you're welcome. Why does your character jitter when standing? So this is actually... Hold on. Not sure what is it caused by, if I'm being honest. It sort of depends on how you land, which is interesting. Hold on, let me try to... Now I won't be able to reproduce this. It jitters a bit and then it settles. Maybe we'll try to use the tunnel. Yeah, I don't know. I'm not too worried about that because, you know, it's gonna be pixelated and the character is gonna be snapped to the pixel grid. So it's probably not gonna be a problem. Famous last words. But yeah, I guess it was just some sort of physics not settling correctly. Looks like a float rounding issue. Could be as well. Cap would imply an additive and you're clamping the result value to your max. I don't know what that means. Like in Dune, they have the device which lets them stick closer to the walls, but they can leave in the middle. I haven't seen the movie yet. Or read the book, for that matter. Are you calculating all the distances to the player every frame, or are you using the AABBs to filter out beforehand? Not yet. Like right now, I believe this one uses AABBs. Hold on. Yeah, we are here. We're using the control box, which is like a really rough AABB of the spline. Quick to calculate. It's basically, you know, if you take a look at all the control points, the control box is just something that encapsulates all of them, right? So it's not tightly wrapped around the spline, but yeah, if it doesn't contain it, then we continue the search. And the physics, of course, does it, right? As well. I can show you. Here is another, you know, colliders with AABB intersecting AABB. Is a rapier function that allows you to like only iterate over the colliders that are, you know, near each other. Okay, 2 hours. I'm gonna take 10 minutes for a little break, and I'm gonna be back with you. I know you started with Rust on this project. How much of a pain has boxing lifetimes mutexes been for you? Not at all. Bevy handles most of this. Like, you don't really need to worry about mutexes or lifetimes for that matter, or boxing. For now, like, I'm assuming as the project grows, maybe it's gonna be a problem, but I don't know. People were saying the same thing about the borrow checker and stuff, and I just don't. I wouldn't say that it's a pain. You know what I'm saying? I feel like it's greatly exaggerated how people talk about this, these features of Rust. But I don't know. I've only coded in it for a month, so Okay, I'm gonna be back. Give me 10 minutes. Quick little break. Okay. I'm back. I was thinking about setting up a timer and I forgot about it. I have so many things that I want to do with this stream. Like setup wise, and I just didn't do any of that yesterday. Maybe I'm gonna try to today. Okay. Got bored, rewrote the inner find closest for loop. Let me see. Can I copy this? The inner, so that would be in the curve section. You mean this for loop? No, that's not the, wait, what do you mean? What part, which portion is that? What's the query? You're checking, oh wait, hold on, that's not gonna be here. I know what you mean. This was in the player controller section. So this is it, right? The query would be interactables. So what are you doing here? You're filtering out anything that's not an anchor, excuse me. But why would you do that? Actually, now as I think of it, like we are interested in any interactable. But I guess your point is the min by key, right? Which is like taking transform and returning the distance. Distance is calculated here. Yeah, that could actually be less verbose. Hold on, let me try. We get closest target and interactable out of this. Okay, so if I wanted to write it like that, see, but I don't like that because I cannot restrict it by, oh, okay, closest distance, never mind, closest distance is infinity. Returns the element that gives the minimum value with respect to the specified comparison function. Returns the element that gives the minimum value from the specified function. Oh, okay, so here you need to compare the two values. And here you just calculate a key that has to be comparable, I assume. Right? Is that what's the definition of it? Yeah, function needs to return B, which has to implement the order, I assume, trait, I'm guessing. Okay, so we can take entity target, and we're not interested in interactable. And then we technically just return this, right, as the distance. And it should be the same, maybe. How is order not satisfied for F32 though? That is the question. Only integers can be ordered. Yeah. That's a bummer, but it feels like it should be. It feels like there should be a function for that, right? Yeah, but this also requires order. Well, we tried. I guess that's simple for loop. It is. Oh, you're dual streaming on Twitch and YouTube, wondering why those messages weren't showing up. Yeah. We are violating Twitch's terms of service by displaying a merged chat, apparently. Although, okay, a quick tangent. I was sort of thinking about this. Hold on a second. Please don't report me, by the way. They don't need to know. Right? So there is this thing. And it says, you do not use third-party services that combine activity from other platforms or services on your Twitch stream during your simulcast, such as merging chat. But here's my interpretation of it, okay? I don't know if anybody got banned for displaying a merged chat, but I feel like they mean something else when they say third-party services that merge chat, because there are services that let you do that, right? They like tunnel messages from Twitch to YouTube and the other way around. Like, I don't think it's only about like displaying the visual merged chat. I don't know. I guess we'll be notified if what we're doing is not legal. What if it's not a third-party service? Exactly. It's a program running on my computer that scraps the data from two chats. You know what's also interesting? Give me a second. I'm gonna show you something that I think is funny. Hopefully, if I can show you that. Because initially I wanted to implement it myself. Right now I'm using social chat, which does this. But what's funny is that if you go to the chat and you just inspect the network connection on the WebSocket, I just showed you my OAuth. I just realized that. Well, that's a problem. Because that's not what I wanted to show you. Please don't hack me. But anyway, if you do that from a not authorized thing, you get to see the default passes that Twitch uses for like logging into the chat. and you can just use this without needing to register your chatbot, which is kind of weird if you ask me. That like this there's no verification even if you're connecting from something else. Yeah, they do use IRC. The YouTube, on the other hand, oh my god, YouTube is using a REST API for their chat, and the funny part is that it wants you to refetch the data every second. So if you were to do that, you would run out of your quota in like 2 hours. So there's really no way to like, legitimately get the data from YouTube without registering like a specific application in Google Cloud and, going through the whole verification process and whatnot. Now I'd notify your Twitch session because that OAuth token is easily lifted from the VOD. Yeah, I'm gonna have to do that. But then I'm gonna... Hold on. Give me a second. How do you do that though? I'm trying to look up some information about that. Oh, okay. I found it. Okay, am I still streaming on Twitch? I think I am. I don't think it resets the stream key, right? It may or may not reset your streaming key, okay. No, I'm still alive. We're golden. Should be safe now. Just to make sure, I'm just gonna check if the OAuth token is different now. Apologies for the technical problems of me being a moron and leaking my own OAuth key. Okay, hold on a second. Just a moment. Okay, it's different now. Can you show us how to use an OAuth key to send messages to your chat? I have no idea how OAuth works, dude. When I tried to set it up myself, I spent like 3 hours just trying to make it work. But there's like, you have a whole developer guide on, you know, on developers.twitch.tv, I believe is the address. And they walk you through the whole process. Though admittedly, doing it on Twitch is much easier than doing it on YouTube. Because Google is absolutely insane when it comes to like the authentication process. You need to go through like 3 different deprecated libraries before getting to the one that actually works. Okay, back to game dev, I suppose. Now we can take care of the field thing. So if we enter the field, we also want to apply some sort of velocity, and this should be easy. Okay, this should be extremely easy, hopefully. So first I need to go to Rapier and actually figure out how to do collision detection. No, not common mistakes. Colliders. Advanced collision detection. The intersection graph is probably what interests us, right? We want to intersection with entity, yeah. Okay, so I don't know if we have access to the Rapier context here. Not yet, but we could have. Intersection with what? Intersection pairs with an entity, and the entity being our player. All the intersection pairs involving the collider attached to the given entity where at least one collider involved in the intersection is a sensor. Oop. The returned contact pair identify pairs of colliders. To check if any geometric overlap happened between the collider shapes, check the returned boolean. Okay. So this is gonna be collider A, collider B, intersecting. If not intersecting, we don't care. And then we're gonna have to get our fields, force fields. There's gonna be a query of what? it doesn't really matter, does it? Right now it doesn't. Well, all we care about is that it has a force field component. And now we just need to check. Also, let's maybe start this. Oh, I guess we're gonna need some data from it. So let's immediately take care of that. We will use this because there's probably something like, you know, the direction of the force field is gonna be stored in here. So right now this is none. And now if our force fields, but I don't know which collider is which, right? There is no guarantees about the order, so I guess we need to figure this out. So if collider A is our player entity, then we want collider B, otherwise we want collider A. And now if our force fields query, is there like a has? Contains? Yeah. If it contains the collider, so the collider is actually a force field, we can, you know, store it. No, wait, because we are actually interested in the component. So instead of contains, we're gonna get. We're just gonna do this. Or maybe not. What's the matter here? Should have a snake case. Oh no, that's true. Okay. Are you happy with Rapier? I took a look at it at some point and it seemed really complex. Physics ain't simple. True, but for a 2D game, it may be more feasible to use a self-written physics system. Maybe, but that's risky time investment. So I'm really happy with Rapier actually. I think it's cool to use. I haven't encountered any problems with it. It is a bit, you know, it's not really well integrated into ECS, but at the same time, I feel like, I know that there is this other crate for Rust, for Bevy, that's like designed specifically. It's a physics crate. I don't remember the name of it, but it's implemented using ECS. Though at the same time, I feel like there are certain problems that are not really well suited for ECS, right? Transform propagation would be one example, because ECS is really about iterating, right? So when you have a data structure that's not really iterative, like, you know, a depth first traversal of the scene graph, you end up with like a really weird solutions. And if you take a look at the transform propagation implementation in Bevy, it's also like really, you know, it doesn't look like it's idiomatic ECS, because it's just not the type of data structure that you would traverse using an ECS. And I feel like physics is kind of similar, right? Like, I don't know much about physics, like all of the like octa trees and whatever, all of the like space partitioning things, but it feels like it wouldn't be that easy to implement in ECS. But then again, there is this crate that's like written in ECS, so maybe I'm just making stuff up. Anyway, I like Rapier. You know, the only problem is that it has like this own separate physics world, which you access via context. So there is some translation that you need to do, but other than that, it works well. When it comes to writing my own physics engine, I don't think I would be able to do that. Just the thought of like figuring out how to make a box, a rigid body, fall down and actually, you know, rotate correctly around the collision points. You know, I feel like I want to use Rapier for that. But for the most part, if you take a look at the physics controller, the character controller, it is mostly custom physics. I'm not really using a rigid body, right? I'm just calculating all of the forces and all of the collisions myself, and then I'm just using Perry for all of the like sphere casting and stuff. Anyway, we have the force field now. So now this is gonna have an even higher priority. And we're just gonna do... First of all, we need to unfreeze the physics. And then let's make up like X for now, right? So this is just like a random direction of this force field. Oh, it doesn't actually matter right now. Would make sense for a game with really simple physics like the classic Asteroid, but with a really realistic physics engine like Rapier or XPPD. Oh yeah, that's the name of the crate, by the way. Bevy XPPD, right? It's months, years of work. Yeah, that's true. What do we have here? Nothing. We are not colliding with it at all. Okay, it's time for a trusty console logging. Let's see if we're even getting any sort of intersection checking. No, we are not. You cannot see the console, but there's nothing being logged in it. Okay, so it is logging entity 4 and entity 21. So entity 4 is our player, and entity 21 does not exist. That's interesting. There's an entity 22 and then entity 20. Oh, this is 21. Okay, I was looking at the 002. Okay, so this is our sensor, but intersecting is false. Am I misunderstanding the docs? because it only finds out about this when we're inside of it. XPBD is the name of the ECS-based physics engine for now. The authors are renaming it soon because they're changing from the XPBD algorithm to a different one. Yeah, they're actually changing to a solver similar to the one that Rapier uses, right? At least that's what I got from reading the announcements. Okay, so first let's try to break it maybe to make sure that I'm understanding it correctly. So let's make this into a non-convex shape and see what's gonna happen. So I'm gonna make something like this, right? So that now if we go here under this little overhang, we're gonna technically be inside of the AABB, but we're not gonna be inside of this shape. Yeah, and it's now logging. Right now it is finding the match, but the intersecting is false, but it's also false here. Let's move it up a little bit. Yeah, so it's correctly detecting the intersection, but not if we're colliding with it. Let's try to move it a little lower to make sure that we are completely inside. Maybe that's the problem. No, it's not. Okay. So here's basically the log that I'm getting, right? It's like the player, the sensor, but then intersecting is set to false. Yeah, intersecting bounding volumes. To check if any geometric overlap happened between the collider shapes, check the returned boolean. Yeah, but the returned boolean is always false. Well, maybe I spoke too soon about Rapier being good. No, I'm just kidding. It's probably some fault on my side that I'm just not realizing. Oh wow, the debug macro is nice. I'll have to use it instead of print line in the future. Yeah, somebody told me about it during the previous live stream. And you can also, oh yeah, you can see it here, right? You can wrap a value in it and then it will get returned from it, sort of, right? So I'm not sure what could be the problem here. It is a sensor. Maybe it has to do with the convex decomposition thing. Where is our field here? Just close the game. What if instead of convex decomposition, it would be a polyline? Oh, what's the problem? Oh no, it works. Okay. Just highlights the error for some reason. Okay, so it still always logs false. I know that a polyline doesn't have an inside, right? But I thought that maybe when intersecting with a polyline, it would be different. Okay, so let's try something even different, even more different, even differenter. And just add like a box. If I knew how to do that. That's a cuboid. We're gonna make it like something big. Let's say 60. Just to see if it actually has anything to do with the collider that we're using. No, it doesn't. It's still false. Your Rust analyzer is acting weird. Yeah, it's like you say. I mean, I don't think that's because of locking files, because we have a separate target for Rust analyzer. But I feel like it may be just Visual Studio Code trying to pick up the errors returned from the tasks, right? Because there is this thing called problem matcher, which I'm assuming it tries to like extract the problems from the command, I think. I don't know, I'm guessing. Because right now I'm having two separate cargo commands running, right? I have this run dynamic, and I have this watch dynamic. And I feel like when this is running, it sort of messes up with the error highlightings and stuff like that. Error highlights. How did you set up the separate target? I set it up somewhere. I set it up globally, I believe, through Visual Studio. Yeah, like this. There's just a different target directory. Maybe for future streams, if it's possible, you can keep the chat half of its current height, so the console will be visible to us as well. Yeah, we could do that. Maybe not like half the height, but you know, at least the last few lines, right, of the console could be visible. Okay, so yeah, I think it would even work nicely in Blender now as I think of it, because Blender displays like custom properties here at the bottom below the chat, so they would be visible as well. Well, anyway, could it be that I'm missing something? Oh, that's interesting. What's the default? Oh, there is no default value of a sensor. That's weird, because it sort of implies that sensor is the sensor component is like wrapping a Boolean value. Where's the field here? But I'm not. But it's not. It's just a tag. What about the player? Yeah, the player is just a ball. Okay, hold on. Let me close all of these tabs because I'm getting lost. What we're interested is the field arrays. Let's go back to the convex decomposition. Okay, so let's see if this is like a problem with Rapier actually. Can we do that? Well, we technically could, but this is a bit complex. Kind of funky how the colliders are 3D. Are they 3D? I don't think they are. So is there something in the context that could help us? Interesting. Oh, let's try this. Intersections with point. See what's gonna happen. With point, and the point is gonna be in the position of the player. This method takes 3 arguments. Oh, and a callback. Okay. Let's exclude the player, because that's always gonna be intersecting. And then we get our collision here in this callback. Okay, let's see. This function takes 2 arguments, but 1 argument was supplied. What's the other argument? Self? What do you mean? Okay, hold on. Expected vector 2, okay. So I need to truncate this. We want to continue the iteration. Oh, I'm silly. It's a method. Like this. Okay. Okay, so it works. If right now I'm only checking the position of the player, so it's like the center of the sphere. And when I enter this collider, it works. So I'm not sure what's up with the player not working. But oh well, you know, it's good enough, I guess, for now. So now we're gonna do if let some field is equal to force fields get collider. This is gonna be our force field. And we're gonna return false to stop iterating. And then otherwise we're just gonna return true to continue iterating. Oh, and that's a result. And this has to be dereferenced, and that should be it. But yeah, it's building. Are you using Bevy 0.13? If so, why are you not using the splines that it comes with? Not feature complete enough? I didn't know about that. Cubic curve. Okay, let's see. I mean, okay, hold on. I'm gonna go back to it. Let's just see if the force field works now. Yeah, it does. Believe it or not, it changes our gravity. And now we cannot go back. Some funky things are happening. But yeah. So we're gonna definitely have to account for this. I kinda know how to do that, but it's gonna require some additional work. But yeah, it just works. Okay, so let's see. Wait, is that it? Yeah, Bevy math. Composed of a single cubic Bezier curve. Cardinal splines, B splines. Like, I guess the point, instantaneous velocity of a point at parametric value t. So is this the first order derivative and the third order derivative? Because that's like really the only thing that I need. If I can get the derivative of the curve, then we should be all set up. Or find y given x. I'm gonna steal this from Motion Canvas. This is actually something that we need. And I was always like, I never wanted to do that because mathematically it's a bit difficult to understand. But if this algorithm can be just yoinked, that's awesome. Oh yeah, yes, compute the first derivative, compute the second derivative. Okay, so yeah, that's interesting. That's really good. I mean, the current implementation that I'm already using because it comes with Velo. But if there's a native way in Bevy, that's awesome. I'm gonna try to migrate to it. They drew graphs in the docs. Yeah, they did. It's kind of cool. Okay, so where's the drawing? Here we go. So we have most of these things. I guess the dash is disabled right now. Let's try to use them together just to see what would happen. Okay, so for example, I'm gonna duplicate the walkable here. And I'm gonna reparent it to this curve. I actually don't know where it is because it doesn't show up in the outliner. That's kind of confusing. Oh, it's here inside of an empty. Okay. All right, so let's see what's gonna happen in the game. Okay, so I know what problem this is. We're gonna have to fix it. But for now, let's just do this. Yeah, so now walkable is here. And that's okay. And I'm gonna duplicate the hook and I can place it here. And we're gonna see what's gonna happen if I use it now. Because technically I should stick to this wall, right? I'm gonna get rid of this anchor. Yeah, the camera is not really working with me. But yeah. Stick to the wall when we use that. That's awesome. So maybe add another walkable. This time it's gonna be probably something like 0.2. Again, we need to make this easier to edit. Because right now it's a bit counterintuitive. Okay, so yeah, that's kind of what I want to do. I want this to be walkable as well. Okay. And then we're gonna edit the extraction tunnel to sort of lead us towards this wall. And we'll see what's gonna happen. Yeah. Whoops. I don't know if we're probably gonna wanna add some way of like unsticking from the wall. Not sure how this would work just yet. Would probably have to be a separate button. Okay, so let's try another thing. Just having a force field somewhere here. And then having an extraction tunnel leading to it. So now technically the force field should take precedence. We're gonna have to make the transformations work correctly. Because right now I can't edit the position of things. Yeah, okay. We can also control, which I think should be the case, sort of control our velocity inside of the field. What I'd also like is some sort of a zero gravity field where we can just freely go in any direction, maybe. Maybe we should do something about this as well. So that we are still able to like go to the other side, even if the extraction tunnel is here, in the opposite direction. Yeah, but I guess we're gonna have to allow the player to escape at first, and then it should probably click together once that's implemented. Okay, so I'm gonna take another quick 5 minutes, 5-minute break. I'm gonna be right back with you in just a second. Okay. One quick thing that I wanna try, excuse me, implementing. Let's try taking this ground and moving it somewhere else. It's kind of this way of using an anchor to get to a force field that's behind an edge, because I think that would be an interesting setup. Right, so we can add a little force field here. Next to this ground. So it's generally too far to reach. But if we use an anchor, it should be possible to kind of do this up and around movement and then land back here. It's the general plan. But for this, we're gonna have to change the direction to -y. Okay, so that works too. Maybe it's a bit too fast. But right now we have no way of affecting gravity, which I think we should probably also add. So yeah, let's add this really quick. First of all, actually, let me comment all of this, since, well, maybe without this crash report. Yeah. And now we can go to the player controller, wherever that is. We probably want something like gravity scale. It's gonna be 1.0 by default. And then gravity is being added somewhere here. Okay, but we don't have access to the player controller here, actually. Let's move this to player physics. That makes more sense, actually. Okay, and so now here we can do physics. Gravity scale, maybe something like 0.25. And then we're gonna have to manually reset it everywhere else, which is, I guess we can just do this for now. We're gonna have to find a better way to handle this. Yeah, now the force field gravity should be a little bit weaker, which I think is gonna be better. Okay, so something seems to be wrong with the player. That's interesting. Let's try running it normally, just to make sure. Oh, it actually crashed. Hold on a second. Okay, so we have some technical issues, which is something I talked about in my previous stream, which is that the linker is now crashing. And yeah, I haven't found a solution to that other than recompiling the entire project, which is gonna take like a solid 15 minutes. But we've been streaming for like 3.5 hours, so I guess that's you know, it's a good idea to end it here then. We finished practically all of the things. They just need some little polish to, work better. Okay, so I'll be streaming tomorrow at the same time, most likely, and we're gonna try to finish like adding the movable boxes and stuff. And meanwhile, today I will first of all fix the fix the linker issue, but also do some of the boring stuff related to these things to make them work better, like allowing the player to escape from the tunnel, and figure out a way to have like zero gravity force fields where we can move freely, because right now the current implementation is really static, it's really fixed. It sort of assumes that you will always try to go like the player can only control the horizontal direction, but if you are in a zero gravity situation, you want to be able to like go wherever, right? So that's what I'm gonna take care of by myself. And yeah, today we're gonna handle boxes. That would be the plan. And maybe also I kind of wanna try migrating to the Bezier curves from Bevy. So maybe if I have time today, I'm gonna do it as well. Which keyboard and mouse do you use? I don't know, it's some Microsoft keyboard. It's not a mechanical keyboard. And it's some Logitech mouse. Really random, really old. Definitely not fancy. Okay. So. Goodbye, everyone. Thanks for tuning in to the live stream. Again, I'll be live tomorrow at the same time. I'd like to try and do it every day and see how it goes for about a week. Okay. Goodbye, everybody, once again. And I'll see you sometime soon.